Hi, it's Jo Karen Hudson speaking. Today we're going to talk about rational expressions, equations, and functions. I will first talk about evaluating radicals or roots on the calculator. Evaluating radicals or roots using the calculator. So we'll first start with the square root of 169. So I'm going to put 169 into my calculator. The square root of 169. There's the square root of 169, and that is equal to 13. I'm going to pull that 13 out, but show you how it looks. On my second example, I have the square root of negative 49. So I'm going to have second square root of negative 49. Now, many of you may understand that that's not a real number, but your calculator will tell you if you forget. It says not a real number. It will say error, not a real number. And that's what we want to write for our answer. We want to write not a real number. Now, when I do my third example, I don't think I'll need the calculator for that. I want to break my fraction down. I've got a fraction under the radical, so I want to write them separately. The square root of 25 over the square root of 64. And I think we all know that the square root of 25 is 5 and the square root of 64 is 8. So I have my final answer there quickly. Now on the next one, notice that the negative is not underneath the radical. On our first example, where we had I guess it was the second example, where we had a negative underneath the radical, it was underneath the radical. You see, on negative, the square root of 36, it's not underneath the radical. This just tells us that the answer will be negative, and we know that the square root of 36 is 6. So our final answer is negative 6. Now, continuing on, we want to find the decimal approximations of the following radicals, starting off with the square root of 91. Second square root of 91. And the square root of 91 is this right here. Okay, and we want to round it off to the nearest thousandth, so that means we're keeping 3 decimal places. We're keeping 3. So we look out here at this fourth digit, and it's a 3. It has to be bigger than 5 or bigger to be able to round it up. So we'll just lop that all off, and it will round up to 9.539. Since this number was a 3, we just take all of that off. Negative the square root of 250. Now this is going to be a negative answer because of the negative out front. Second square root of 250. And that turns out to be, I'm going to pull that out and so we can talk about it. Now when you're rounding something off to the nearest thousandths, that means you're going to keep 3 decimal places. And you're going to look 1 digit to the right of that third one into that fourth spot to just try to decide whether to drop it off or to add 1 to this third digit to the thousandths place. And since this number is a 3, we're just going to lop that all off. 15.811. Now we'll do just a little bit of a review. This is what we're going to learn that is new in this lesson. We have already learned that the domain of a polynomial function is going to be all real numbers or negative infinity to positive infinity unless you have to eliminate something. And we learned that the domain of a rational function, you remember when we had like 7 over x minus 2, and we had to eliminate something from the denominator by setting the denominator equal to 0. We had to add 2 and add 2. So we had to eliminate the point x equal to 2 because x can't be equal to 2 because it will make the denominator 0. So on the number line, when you eliminated x equal to 2, you just made a circle there at 2. And so the graph actually went from negative infinity to 2 and from 2 to infinity. So the domain of a polynomial function is going to be all real numbers except if you have a denominator or except if you have a radical. When you have a radical, what's underneath the radical has to be greater than or equal to 0. So let's try a few of these. Determine the domain of the function. Write the solution set in interval notation. So whenever you have a radical, what's underneath the radical, which is called the radicand, 25 minus x has to turn out to be greater than or equal to 0. So I'm going to solve this by subtracting 25 from both sides. So I have negative x is greater than or equal to negative 25. That's like negative 1x, so I'm going to have to divide both sides by negative 1. And when I do that, it turns the inequality around, and I have x is less than or equal to 25. Now, what does that look like when x is less than or equal to 25? I have 25 less than or equal to is going to go to the left. It's going to have a bracket because of the equal mark, and it's going to the left all the way back to negative infinity. So the interval from left to right will be negative infinity to 25 bracket. Final answer there. Our next example, you see we have f of x is equal to the square root of 3x plus 7. So what's underneath that radical, the 3x plus 7, has to turn out to be greater than or equal to 0 because we don't want to have a negative under the radical. So it has to be 0 or it has to be bigger to keep from having a negative under the radical. So we're going to subtract 7 from both sides. That'll give us 3x is greater than or equal to negative 7. And then we'll divide by 3, and we'll have x is greater than or equal to negative 7/3. So what that looks like on the graph, we have negative 7/3, and it's greater than or equal to, which means we're going to have a bracket. It's greater, so it's going to point toward the right all the way to infinity. So it's going to be from negative 7/3 all the way to infinity with a bracket around the negative 7/3, and infinity always has a parenthesis. Okay, another example, we have f of x is equal to the square root of x minus 9. We know that what's underneath the radical has to be greater than or equal to 0. So if we add 9, we'll have x is greater than or equal to 9. And what does that look like? Well, you have to find the 9. Notice that it has an equal mark, so it's going to have a bracket, and it's got to be greater than 9, so it's got to go to the right all the way to infinity. So it starts at the left, it starts on 9, it'll go all the way to infinity, bracket on the 9, and parenthesis is always around infinity. Okay, continuing on, find each function value if it exists. And what if it exists means is if it's not the square root of a negative number. If it's the square root of negative 7, we're going to write not a real number, or we can write does not exist, either one. Not a real number or it does not exist. So we'll start off first with the square root of 3x minus 9. So I'm doing f of 9, which means I'm going to plug in 9 where the x is. So I have the square root of 3 times 9 minus 9. Square root of 3 times 9 would be the square root of 27 minus 9. 27 minus 9 would be the square root of 27 minus 9 would be the square root of 18. And now it wants me to round it off to the nearest hundredth, so I'm going to have to grab my calculator for that. Square root of 18, second square root of 18. That gives me that. I'm going to pull it out so that I can round it off to the nearest hundredth. When I round it off to the nearest hundredth, that means I'm keeping 2 decimal places. So I look out at the third one, and the third one is a 2, so I'll just lop all the rest of that off. So it will be 4.24. Final answer for that one. All right, f of 6. So this time I'm going to plug in 6 where the x is. So that I will have the square root of 3 times 6 minus 9, which would be the square root of 18 minus 9. 18 minus 9 is 9, so I'll have the square root of 9 is equal to 3. And that one I don't need to, it comes out even, doesn't it? And then I'm going to do f of 3. So this time I'm going to put in a 3 where the x is. So I have the square root of 3 times 3 minus 9, which would be the square root of 9 minus 9, which would be the square root of 0, which would be 0. So this one turns out to be 0. And the last one of these is f of 2, which means I'm going to be putting in 2 where the x is. So I'll have the square root of 3 times 2 minus 9, which would be the square root of 6 minus 9, which would be the square root of negative 3. And oops, what about the square root of negative 3? It's not a real number. Or you might say that it does not exist. Depends on how they phrase the question in my math lab. Does not exist or is not a real number. All right, now I'm going to do the cube root of 125. So when you do the cube root of 125, we can use the cube root functions, which we'll have to go to math. On the calculator, we'll have to go down to 4. Math 4 gives you the cube root symbol. So I'm putting in the cube root of 125. And what does that give us? Cube root of 125 is 5. So don't have to round that off at all. Cube root of 125 is 5. Now I'm going to do negative the cube root of 125. So I'll have negative, and then I'm going to do math 4 to get the cube root symbol. So I'm going to do negative the cube root of 125. And this time, you see the negative out front makes the answer become negative 5. This answer is negative 5. Now I'm going to do the cube root of negative 1331. So I'm going to do math 4 to get the cube root symbol, and I do negative 1331. Now, this is not a square root of a negative number. This is a cube root of a negative number, and I can do the cube root. It's an even root of a negative number that you cannot do. And this turns out to be, it comes out even, and it turns out to be 11, or actually it turns out to be negative 11. And that's because negative 11 cubed gives us negative 1,331. It will check back if you want to try to check it. And then I'm going to do the cube root of 120, the fraction 125 over 343. So I need to split it up first. The cube root of 125 over the cube root of 343. I'll grab my calculator. And I'm going to work these separately. Math 4 to get the cube root of 125. And then I'm going to do math 4 again to get the cube root, math 4 again, I've got to do it again, I made a boo-boo, math 4 again to get the cube root of 343, and that turns out to be 7. So I will actually have for this one 5 over 7. Okay, we're almost done. I'm going to find the function value if it exists, and then I'm going to round to the nearest hundredth. So I'm going to start off with f of x is equal to the cube root of x minus 2. And the first time I'm going to put in negative 6 where the x is. So I'll have the cube root of negative 6 minus 2, which would give us the cube root of negative 8, which is equal to math 4. The cube root of negative 8 is equal to negative 2. There we go. Cube root of negative 8 is equal to negative 2. So you don't have to round that one off. That comes out even. Now, the second time, I'm going to put in 10 where the x is. Put in 10 for x, so I have the cube root of 10 minus 2, which will be the cube root of 8. So I'm going to get my calculator. Math 4 gives me the cube root. I'm doing 8, and the cube root of 8 is positive 2. And that shouldn't be such a surprise. The cube root of negative 8 was negative 2. The cube root of positive 8 is going to be positive 2. Then I'm going to do f of 0. So I'm putting in 0 this time where the x is. 0 where the x is. So I have the cube root of 0 minus 2. So I'm going to get my, which would be the cube root of negative 2. And I can put that in my calculator. And I can do the cube math 4, doing the cube root of negative 2. That turns out to be this. And I need to round that off to the nearest hundredth. That means I'm going to keep 2 decimal places. So I look 1 out, and it's bigger than 5, so this would be negative 1.26. I have to add 1 to that hundredths place since this was bigger. This 9 was bigger than a 5. And the last one is f of 2. F of 2 means I'm putting in 2 where the x is, so I'll have cube root of 2 minus 2, which would be the cube root of 0, which would be 0. Final answer there. This is Jo Karen Hudson. Thank you, and have a wonderful day.